Think back to the early days of the internet. It was a physical, noisy environment. Racks of servers, tangled cables, and a constant flow of traffic. Back then, data moved completely out in the open, in plain text. If you wanted to log in to a remote computer, you had to type your password and send it across that busy network. It traveled completely exposed, which was a lot like shouting your bank PIN across a crowded room. Anyone sitting on that same network could want a simple eavesdropping program and scoop up your login details right out of the digital air. The internet desperately needed a way for computers to whisper securely across the globe. It needed a mechanism that allowed you to prove exactly who you are without ever actually sending your password over the wire. That solution is called Secure Shell, or SSH. Think of SSH as a heavily armored, soundproof tunnel built directly between your laptop and a remote computer. To make this work, SSH replaces passwords with a two-part locking system. First, there's the public key. You can think of this as an open padlock. You can safely hand copies of this open padlock to any computer on the internet. Then there's the private key. This is the actual physical key that is designed to fit perfectly into that specific padlock, and it never, ever leaves your computer. When you try to connect, the remote computer checks your open padlock. It asks your machine to prove it holds the matching physical key. Your computer performs a quick mathematical check, unlocking the connection. Because the private key itself is never sent over the network, eavesdroppers have absolutely nothing to steal. You get absolute verification of your identity, entirely replacing the need to type a vulnerable password. Over time, computers get faster and smarter at guessing passwords. A digital lock that took 1,000 years to crack a decade ago might take a modern computer only a few days to break. For years, the standard lock was a mathematical format called RSA. It still works, but to withstand those modern guessing attempts, RSA requires incredibly long, bulky strands of code. It's like dragging around a massive, heavy iron padlock to secure your front door. Today, the state-of-the-art alternative is a format called ED25519. You can picture this one as a sleek titanium smart lock. Because this new lock uses a completely different type of mathematics, the keys are a fraction of the size. That smaller footprint delivers faster connection speeds and a much tougher defense against modern cracking attempts. If you build an impenetrable, armored tunnel but secure the door with an outdated, easily picked lock, the tunnel itself loses its value. In a real-world business, system administrators are constantly handing out these public padlocks. They give them to new employees, automated applications, and temporary contractors to keep everything moving quickly. Over the years, this creates a massive buildup of forgotten, unmonitored locks scattered across the network, an operational hazard known as key sprawl. A contractor finishes a project and moves on, or an employee leaves for a new job. But often, nobody remembers to go back and remove their public padlock from the company's servers. Those forgotten padlocks stay active, turning into invisible backdoors. If a hacker manages to steal that former employee's old private key from their personal laptop, they can bypass all the modern firewalls and walk straight into the network. The most advanced cryptographic math on Earth cannot protect a network if the organization simply loses track of who is holding the keys to the front door. Protecting a massive system starts right at the desk of every single user. How you handle your personal keys directly impacts the security of the entire network. The first rule is to always use a passphrase. This acts like a mandatory PIN code for your private key file. Even if a thief copies the file off your laptop, they can't turn the key without knowing that secret phrase. The second rule is to never, ever share your private key. The entire SSH system is built on the fact that only the public padlocks are copied and distributed. Your private key stays with you. The third rule is active rotation. Treat your keys like they have an expiration date. Regularly delete your old keys and generate fresh ones using modern, compact mathematics like ED25519. By treating your digital credentials with the exact same caution you use for your physical house keys, you ensure that even if your personal device is compromised, the broader network stays safe. Individual habits are important, but network administrators also have to proactively clean up that sprawling mess of historical access on the servers. Every server contains a specific text file called authorized keys. You can picture this as the server's master guest list, detailing the exact shape of every single padlock allowed on that machine. Historically, the only way to clean this up was through manual labor. Administrators had to sit down, read through these massive text files line by line, and individually delete the entries of former employees or retired systems. Today, large networks rely on automated key management software. These programs constantly sweep the entire network, hunting down abandoned padlocks and instantly revoking them. Through continuous, aggressive auditing, an organization takes back control, turning a sprawling mess of forgotten doors into a tightly locked fortress. Secure Shell is the invisible infrastructure holding our digital lives together. It allows the world's computers to communicate safely over hostile networks. But those secure tunnels will only ever be as strong as the management of the keys that open them. Tightly control where your public padlocks go, fiercely protect your private key, and you keep the hackers locked out for good.